Everyone, so for 3.3 async, we're going to be reviewing our exponent properties. We talked about these in class a little bit, and I'm going to go through and do a couple of these problems for you, kind of one of each to get you started. But first, let's talk through the properties that we reviewed last class. So there's four basic properties we deal with exponents. So the product rule tells us if I have two bases being multiplied together, then I can add their exponents. So x squared times x to the third power becomes x to the fifth power. The power rule tells us that if I have a exponent to an exponent, so power to another power, something like this, then I just simply multiply those together. Quotient rule tells me if I am dividing two bases, again they have to be the same base, then I can just subtract the exponents. So x to the fifth over x cubed becomes x squared, just 5 minus 3 gives us the exponent. And finally, a negative exponent means we want to switch sides. So for example, x to the negative a becomes 1 over xa. So if we have a negative exponent, we can make it positive by dropping it into the denominator. Or if we're starting in the denominator, by bringing it up top. Okay, so let's take a look at a couple of the problems we have on this worksheet. Alright, so I've grabbed a couple problems from your async work. Just kind of try to grab a couple of each type so that you can get an idea about how to solve the other ones. Okay, so consider these freebies and you can work out the other ones on your own. Okay, so first up, number one, we've got a product rule. So I've got 3x cubed times 3x. So essentially I'm multiplying four things together here. 3 times x cubed times 3 times x. Doesn't matter what order we multiply things in, so I'm going to take care of my like terms together. 3 times 3 is 9. X cubed times x is x to the fourth power. Remember that when you see a variable that doesn't have an exponent, it's always a 1, right? We assume that there's a 1 there. So 3 plus 1 is 4. All right, let's take a look at the next one. We've got m squared times m squared, sorry, over m squared times 2m cubed. Okay, so there's a fast way and a short way to do this problem. What I would do when I was actually looking at this problem would just take a look at this and see that I have the same term on the top and the bottom, m squared over m squared. So I know that anything divided by itself is just 1, so we can cancel that out, which means my answer is just going to have a 2m cubed on the bottom, and there's nothing left for the top. So remember when we cancel this out, we do so because m squared divided by m squared is equal to 1. And times 1 doesn't really do anything. So don't be mistaken. When you cancel something out, it's not 0 left over, it's 1. Okay, but what I just did doesn't really follow the whole product rule thing. So let's do this by using our exponent properties and see if we get the same thing. Oops, that's a weird shape. All right, so we have m squared on the top and the bottom. I don't know why I wrote a 1 there. Okay, so if we were doing this with our exponent properties, then we would simplify the bottom first. So we get 2m to the fifth power, right, because 2 plus 3. And then I'd use my quotient rule. I'd do 2 minus 5 to figure out the exponent for m. And I would get negative 3. So my answer would be 2m to the negative 3. Sorry, that 2 is still on the bottom. Be m to the negative 3 over 2. Now remember that a negative exponent means that basically we can make it positive by switching sides. So that m to the negative 3 becomes 1 over m to the positive 3. We still got this 2 hanging out. So we get the same thing. I find this a little more complicated to think about, but when we cancel something out, we're essentially taking care of that in the same way. All right, moving on. Okay, on this one I got a bunch of stuff going on. I got a times b to the 0th times a cubed all over a cubed times b squared. Okay, so the first thing that jumps out is I have a b to the 0th power. So one of our properties we didn't talk about just now, but we did talk about in class, is that anything to the 0th power is equal to 1. Okay, no matter what it is, it could be b, it could be x, y, z squared, right? Anything to the 0th power is equal to 1, right? doesn't matter what it is. With one exception, 0 to the 0th power is undefined. But anything else to the 0th power is equal to 1. We can prove this really quickly by thinking about our quotient rule. For example, if I had b squared over b squared, well, the quotient rule tells me I do 2 minus 2, so I get b to the 0th power. But also, intuition tells me anything divided by itself is equal to 1. So, same dealio. Okay, so that being said, b to the 0th power is useless. That's just times 1, which doesn't do anything for us. Okay, so now let's simplify the top. I got a times a cubed, so a to the 4th. And then I've got a to the 3rd over b squared on the bottom. Now I can simplify the a's. So I got 4 on top minus 3 on the bottom, so I've got a to the 1st power, and it's still over b squared. So again, kind of like before, we canceled out 3 of our a's. All right, moving on to number 9 here. This one's interesting because we've got a negative involved. So we've got negative 2 times n squared. Now, what's really important is these parentheses are doing a lot of work here. This is not the same thing as saying negative 2n squared, because in this situation, the 2 is being squared, the negative is being squared, but not here. Over here, just the n is being squared, and we leave the negative 2 alone. So those parentheses are there for a reason. It means we're going to square everything inside. Okay, so I'm going to think about this as negative 2 squared times n squared. All right, we can kind of break those up. So negative 2 times itself is positive 4. N times itself is n squared. And finally, the last one down here, not only do we have a negative base, but we also have a negative exponent to deal with. Okay, so number 10 here. All right, so we said a negative exponent means that we can take that term and put it in the denominator and change it to a positive exponent. So I'm going to rewrite this. I'm going to take that x to the negative 3, and I'm going to think of it as x cubed in the denominator, so 1 over x cubed. This negative 2 is not involved with this negative exponent, right? This is not attached to that. If we had some more parentheses like this, then the negative 2 would drop down as well and get cubed, but it's not. So we're just going to keep it up here. Okay, and this thing is still, the whole thing is still being squared. Okay, so we've seen this before. How do you square a fraction? Well, if you need to square a fraction, you just square the top and the bottom separately. So 1/2 squared is 1 squared over 2 squared. That's 1/4. All right, so negative 2 squared is positive 4. X cubed squared, so remember power to a power, we multiply. So x to the 6th power. All right, hopefully this helps you get started. These exponent properties can be a little tricky, but do your best with these. Use these examples as a guide and get the other problems done. Your best way to upload this is to do everything on paper and then take a picture and upload that. Try to keep your work nice and organized. Or if you want to use a digital whiteboard like this or something like that, that's awesome too, as long as you can show your work.